Okay, we've been given a differentiation question that we need to approximate a change in the dependent variable when the independent variable x changes from 2 to 2.01. Now for these small changes or incremental changes in the independent variable, we can use the approximation delta y over delta x is approximated by dy over dx. Now what this means is that for small changes in the independent variable, there aren't going to be too many changes in the gradient of a function. So what we can say also is that if we're looking for the approximate change in y, we can rearrange this to be the approximate change in y, or the incremental change in y, can be approximated by the derivative or the gradient at the original point, x equals 2, multiplied by the incremental change in x. Great. Now what we need to do now is we need to first find the gradient of this gradient function of this. So the way we're going to do that, let's just chuck out in a different color, make it a bit easier to see. So we're going to find dy dx. That's not very hard to do. It's just going to be 9x squared plus 2. Cool. So we know in this case that x is going to be equal to 2. We know that delta x, or the incremental change in x, has got to be equal to 0.01. And from there, we can just find the incremental change in y. So what we're going to do is we're going to go, well, the incremental change in y then is going to be equal to 9 times 2 squared plus 2. And then we're going to multiply that whole lot by the incremental change in x, which is 0.01. So what do we have here? We have 9 times 4 is 36, plus 2 is 38. Times by 0.01, which is equal to 0.38. So what we can say is when x changes from 2 to 2.01, the approximate change in y is 0.38. Now what we can actually do is we can, if we wanted to, we could compare this to the actual change in y, but for the purposes of this question, it's not important. So just in summing up, what we had to do is we have to identify that this is a small or incremental change in x. Then we can use this incremental change approximation. We can rearrange it slightly to get the incremental change in y with regards to the incremental change in x. We then differentiate the function to find the gradient. We then plug in the values that we have, x at the initial point, the incremental change in x, and that gives us the incremental change in y.